Hi, this is Mark. In this segment, I'm going to cover the ETS Practice Exam. I'm going to there's 40 problems for this exam, and I'm going to cover around 8 or 9 per segment. You can find this exam on Google if you search the ETS Math Practice Exam PDF. It should be the second option available. And this is, I'm going to go over multiple ways to solve each problem. I think on the GRE, it's very important to try to solve the ETS practice problems because the level of difficulty is very similar to what you're going to find on the exam. They cover the distribution of problems is pretty similar. There's a lot of quantitative comparison. These are the key problems that you want to focus on. It's very important to know your fundamentals of algebra and geometry. Do not memorize formulas, just know good conceptual grasp of just the fundamental knowledge. And then from there, it's really just working on with the given information and finding ways to prove the answer, because what the answer choice is given, like for instance, quantitative comparison, you have A, B, C, D, where A is great for A, quantity A is greater. For B, the answer choice is quantity B is greater. C, two choices are equal. A equals B, or D, the relationship cannot be determined. Well, if you're given information such that there's multiple scenarios, and in scenario 1, for instance, you have A greater than B. In scenario 2, you have A less than B. Well, then you can conclude your answer is D, because essentially it's not absolutely true. So A, B, and C, the answer choices are for absolute truth. So that's the key tip that I have, and I'll provide more tips along the way as I go. But let's start with problem number 1 right here. The key information is, notice how the height is equivalent. You also notice the hypotenuse of triangle A is twice the length segment right here. So to approach this problem, I'm going to do 2 different ways. Without knowledge of the Pythagorean theorem, you can kind of intuitively figure it out, and ultimately geometrically it's also a good way you can find it out or solve it. And I'm going to do the geometric route. So if you take, for instance, if you take a circle and you have an inner circle such that the radius of the outer circle is 2 times the radius of the inner circle right here, and you know why I'm drawing this. I'm drawing triangle A right here. So this length we have is 8. This is X. And the key here is anytime you have a circle, it's really just a square. You have a square inside the circle. And right here, same thing. If we had like a square, you have a square, and basically you have four squares within here. And this is, each segment's equal to the radius. So we know that this is 4, this is 4, this is 4. So what you end up having is you have another triangle that connects the endpoint. And so essentially what I'm drawing is you have X, you also have, this is Y, and this is 4 and 4 from here to here. X covers the whole range. And what you want to do is, like, basically if this is your radius, new radius Y, if you drew like a circle that goes around this, basically around this point right here, you'd figure out, you can draw another square and you get another point right here. This is a projection of Y onto this line. So we have a length of X and we have a projection. This is easy to determine that Y, the projection on Y, is such that Y is going to be less than X. It's very, you notice that you'd have to have a very large circle somehow that goes like this, and it kind of it contradicts, because you can't really go in this direction. You have to go to draw a circle. The change in Y and the change in X are always continuously or changing throughout the circle, makes it symmetric. So you can figure out this way, but also using the Pythagorean theorem, you have, like, if you have A, B, and C, we know that A squared plus B squared equals C squared. Right here, I'm going to make an assumption. I'm going to go a different direction. I'm going to assume, you can also make these assumptions anytime on a GRE to figure it out by contradiction. I'm going to do it by contradiction. So we're going to assume that x equals y, so that x squared equals y squared. And this is always going to be true. X squared, you just square both sides and you have x squared equals y squared. And it's always going to be a positive value. And then what you find is, now by substitute for the triangle 2, so for triangle 2 you have 4 squared plus 4 squared equals y squared. So 4 squared is 16, so you have 16 plus 32. 16 plus 16 is 32 equals y squared. And so when you do substitution by using assumption, we can find that y squared now plus 4 squared, which equals 32, plus 16, which we know is 48. We have this is not equal to 64. In fact, 48 is less than 8 squared is 64. So therefore, we can conclude y is less than x. And this means x is greater than y, or a is greater than b. So the key information here is that when you're solving this, you find that for it to be true, you know that the equality has to hold. And that means y equals x, because x has to be, you know that x is a larger value. That's why it equals to this 8 squared. So therefore, y is less than x. And there's multiple different ways to approach this problem. It's just, it's good to know the hypotenuse or the Pythagorean theorem. It kind of helps if you have that in your repository. You don't necessarily have to, but it definitely is very important to know the fundamental knowledge, or at least the concept, and know how to derive it. Now, problem number 2 is you have a numerical value you're comparing with a variable x and y, with x and y. Now, the given information also has a variable, so you want to connect these two together generally. So what you find is with this problem, you need to know, you start with the given. So you're given x minus 2y, and you're given x plus 2y. And you're saying that's equal to 4. Well, you need to know how to FOIL these terms. So what you end up having is you take the inner terms, and the intermediate, you multiply also the intermediate terms. This is like 1, 2, 1, 2. We have 1, 1, but then we have 2, 1, or this is the second term of this parenthetical unit, first term of this parenthetical unit. And then you add now the first term of this parenthetical times the second. So those are like intermediate, 1, 2, 2, 1, 1, 2. And then you have the outer terms, which is 2, 2. So essentially the second and the second term. So when you have a minus and a plus, the intermediate terms cancel. So what you find here is you have x times x, and you have minus 2yx plus 2yx. Those are your minus 2yx plus 2yx. Your intermediate terms, and then the outer terms is minus 2y times 2y. This is a plus and a minus. So these cancel, and you're left with x squared minus 4y squared, which we know is actually this. And we know that this equals to a, which also we know it equals to 4, which we know is less than 8. So therefore, a is less than b. So that's all for that problem. It's key to know like these algebraic relationships. Now, for the third problem, it says a certain recipe requires 3/2 cups of sugar and makes 2 dozen cookies, and then you're provided 1 dozen equals 12. So this is the key information. So we know like basically when you have 3/2 goes to 2, we know that this is cups of sugar, this is dozen cookies. So anytime you have this, it's really a fractional relationship, and I can show you can do it in any such way to manipulate, as long as the proportions are equivalent. So now if what you multiply on one side has to be done to the other. So if you multiply both sides by 2, for instance, 2 goes to 3/2, and this ratio goes to 2 times 2 cookies. So now this is 6/2, which is 3, goes to 4 dozen. So this is cups, this is dozen. So given this information, we know that 1 dozen equals 12 cookies. So this is 4 dozen, right? So we know that 4 dozen equals 12 times 4 cookies, or 48 cookies. So in this relation, this is also a fraction, and it doesn't matter how we do it. So we have 3 cups per 48 cookies, or 48 cookies per 3 cups. So we want to go with this one because we want the numerator, the relation, to be cookies per cup. So we know 48 divided by 3 is 16 per cup. So that means 2 cups equals 2 times 16 cookies per cup. So basically, you're just bringing a multiplier essentially. So this is 2 cups and they cancel. If this was 2 cups, and there are 2. So essentially the units is how many cookies. So 2 cups, it should be cups, and they cancel, and you're left with 32 cookies. Which is, we know, is greater than 30 cookies. So quantity A, this is a key. It says amount of sugar required for the same recipe to make 30 cookies. Now, we know that you need more sugar. It's a proportion. The sugar is proportional to cookies. So if you have less cookies, that means less sugar. So in this case, because B is greater than A, so in this case we know B is going to be greater than A, because you have more cookies proportionally, therefore more sugar, and therefore 2 cups requires more sugar. So that's how you do this, and there's multiple different ways, but it's easier to not work with fractions. It's better to work with whole numbers. So that's my tip, just to convert it to a whole number so it's easier to work with. Okay, so now let's work on the next segment. So or problem. So for this problem, it says a power station is located on the boundary of a square that measures 10 miles on each side. 3 substations are located inside the square region. Inside, that's a key word. 10 miles. Boundary is a key word. Okay, so with quantity A, it says the sum of the distance of power station relative to each of the substations, 3. And then this is 30 miles. So the key is you want to find working with A. So what you do is you first draw your square. 10 by 10 by 10 by 10. Let the power station, you can assume, let's just say P is, it says the outer boundary, meaning it's on the outer, anywhere along this outer boundary. It really, it could be anywhere ultimately, but to solve this problem, you want to go with scenarios. There's multiple scenarios. So notice how this segment right here, let's call this L. We know that L is going to be greater than 10 by the Pythagoras. And also just because it's like the A squared plus B squared C squared, which you can prove in multiple different ways. I'm not going to go over the proof just for sake of time, but we know that L is going to be greater than 10. In fact, L is equal to root 2 times 10. So what you want to do here is, let's suppose now we have scenario 1. Let's just say the scenario 1 is, let's say the substations are very close to A. So if we know the length is 10 for each, so we have a power station. And if you can make them like here, here, here. So it's inside the boundary, and we're doing the distance from power station to each of the 3, and we're adding it up. But we can make the distance very small, like we can make the distance approach 0. So here the length of substations, or length of substations, let's just say the from P to substation 1 is like, we can call L1 from P to S1. L2 is P to S2. and then length 3 is from P to S3. So here is the sum of Li from I equals 1 to 3, or L1 plus L2 plus L3 is going to be less than 30, because L1, L2, we can make it such that is approximately 0, assuming it's close to P, but it's still inside the boundary. Now, scenario 2, we can consider now. We have P. We can make one of them very, very close to this end point, this point, and one very close to this. And because we know that this is 10 root 2 is greater than 10, so basically now the length 1 is approximately equal to 2 times 10 plus 10 root 2, which is going to be greater than 30, because essentially 10 root 2 is greater than 10. In fact, it's 1.41 times 10, so it's quite a larger difference. So in this case, we know for scenario 1, we have scenario 2, though, we have A is greater than B. So therefore, we have the answer choice D. So this is a key, like knowing that like you need to know the different scenarios. And they don't really say exactly where the substations, so that's key information right here. You don't know where the substations are relative, so therefore you have to kind of come up with the logic of where, of all the, because they could be anywhere. You don't want to come up with a million scenarios. What you want to come up with is a minimum and the maximum. And I'm going to go over the next problem, which actually covers that as well. So this is a problem. So problem number 5. We're going to focus on, so this is a given information. So what we have is, we have 6 is less than x, less than 7, and we have also y equals 8. So if we divide both sides by y, we have 6 over y less than x over y is less than 7 over y. Because y is 8, we have 6 eighths, which equals actually 3/4, which happens to be 0.75, less than x over y, less than 7 eighths. So we already know right here, B is 0.85. So we know that 0.75 is less than 0.85. And so if we construct this like 0.75, 0.85, if A equals to here, this could be A. Well, we know that A is less than B, and this relation still holds true. It's still true that because if x over y is less than or greater, this is saying x over y is greater than 6 over 8. Well, true, and yet it's less than 0.85. So therefore A is less than B. Now, we need to find what is 7 eighths equal to. Now, what you want to do here is, you notice you want to get it out of 100. So if we did times 10, so we do times 10 equals, let's just say we're going to multiply, how about, so if we do like 7 times 10, we got to do, we're multiplying really by 1. 10 over 10 is 1. This is 70 over 80. So we have 70 over 80. We want to get out of 100, so it makes it easier. So we know that 80 is really just is 4/5 of 100. It's so you have 20 times 5 is 100, so 80 is 4 times 20. It's just 4/5 of the way. It's 80%. This is 80%. So if you take the inverse relation, if you flip 5/4, if you take 5/4 now by 80, we end up getting 100. So you divide both sides by 4/5, you get 5/4. So basically now the logic is you're going to take 70 times 5/4, and you're going to multiply 80 by 5/4. And you know the bottom is 100, so this is 350 over, you're just multiplying the 70 times 5 and you have 350 over 4 times 100. So this is going to be 350 over 400. Okay, so now given that information, we also know 0.85 is 85 over 100. And we do this times 4 equals 80 times 4 is 320, 5 times 4 is 20, so it's 340 over 400. 4 over 4, so we're multiplying by 4 over 4. So the relationship's the same. So 340 we know is less, so right here we have 340 and we have 350. So for this case, 0.85, this is 0.85. So we could have like A to be anywhere in here. So now we have A is greater than B in this scenario. So before we had A less than B, now we have A greater than B, scenario 2. So scenario 1, A less than B. Scenario 2, A greater than B. And now we have therefore D. So again, we have different scenarios and they're not equal now, absolutely. And we focus on the endpoints. So it's a very similar problem as the previous one. So these can be tricky, but it's key to focus on the minimum and the maximum and to solve these types of problems, and it can get you to the correct, in the right direction. So now let's go on to the next problem. Question number 6, you're given O is the center of the circle with the perimeter, so that's given information, perimeter is 6. Quantity A is the circumference, okay, quantity B is this numerical value of 12. Okay, so you want to, if you start out with the circle, O's here, and you notice that, okay, notice that this is a radius right here, and this is also the radius. And the key information here is if you draw a line segment, there's no angle with this, but let's say you create a small angle. Say this is zoomed up, and this is dy. Dy just means very small distance, y. And this is the angle, theta. So let's say theta is very small. Well, this whole distance is proportional, so dy is proportional to the angle, and directly proportional. So basically, if you have like, let's say this is 60, and you have angle x and angle y, what you find is because the angle y is associated with r, angle x is associated with r. So this is a key relation. They're associated with the same length, r equals r. So basically, we know that x must be equal to y. So therefore, x can replace y, and we also know the sum of triangle, or the angle of the triangle, I would just say the sum of angles of all in the triangle equals 180. So sum of all the angles within the interior, these are interior angles of the triangle, equal 180. So we know now that x plus y plus 60 is 180. So x equals y. So therefore x plus 60 is 180. Or 2x plus 60 is 180. And then you can bring this, you change the sign, positive becomes negative, and you're left with 2x equals 180 minus 60, which is this 120. And therefore you divide both sides by 2, x is 60, which is now implies this triangle is equilateral. So triangle we know is equilateral. So we're basically given 60, 60, 60. And this is just x, because all the sides are equal. So now we have 3x is the perimeter is x plus x equals 6. So x we know is 2. So if x is 2, this is also equal to r. X equals the radius. So the perimeter, the circumference is 2 pi times r, or 2 pi x, which is this 2 pi times 2 equals 4 pi. So we know pi is 3.14 dot dot dot. So this happens to be equal to 4 times 3.14, which is greater than 4 times 3 is 12. So this is A greater than the B, which is 12. So that's a way to solve that problem. And see, I gotta go a new section here. So yeah, the key is just knowing the radius. This is projecting to the radius on both sides, and notice that the angle is associated with the length of the triangle. And then from there you can utilize the logic to solve and figure out that this is quantity A is greater than B. Okay, so now the question 7, A says a standard deviation of a set of 5 different integers, each within or between 0 and 10. B states a standard deviation of a set of 5 different integers, each within or between 10 through 20. So notice how they're equivalent set of numbers. Also, the range is the same. Now, what I mean by that is, like, let's draw a line segment. We draw this from 0 to 10, draw another line segment from 10 to 20. The range is equivalent, meaning the distance. So the mean is always going to be the midpoint, the average. This is average. And we draw a line that between the midpoint. Now, the median, or the standard deviation, what it represents is the relative distance, or it's a distance relative to the mean. So the distance of the 5 different integers, or the integers, each of them relative to the mean. So basically, let's say we take scenario 1. For instance, we can draw, we're going to draw 0 to 10. Here's the mean. Let's just suppose they're clustered very close to the mean. Anytime the numbers are clustered close to the mean, that means the standard deviation is going to be small, because it's a small distance relative. Now, let's suppose on scenario 2 that for the second case, they're clustered far from the mean, closer to the endpoints. So in this scenario, the standard deviation of A is less than the standard deviation of B. Now we're going to go through scenario 2. Scenario 2, we're taking from 0 to 10. We're taking the midpoint. Let's suppose now that each of the set integers are spread far from the mean. And in case 2, or the other option, they're spread very close to the mean. So in this case, the standard deviation of A is greater than the standard deviation of B. Horrible handwriting, but I'm starting to trying to get used to this. So the key here is that we have we don't have it true for all cases. So what I mean by that is, again, we need to, or this relation implies, so for 1, we know that A is less than B. And for 2, we know that A is greater than B under the given scenarios. So therefore, we know answer is again D, because it doesn't hold true in every single case. And that's the key, or the critical, bear with me for a sec. That's the critical information. So again, this is why on the GRE, you need to consider all the options that you can and find counterexamples when needed. Now, the last problem I'm going to cover, or 2 more problems. So for this one, we're given, the key here is we're given that x is greater than 1. So what that means is we're dealing with positive numbers. That's key, especially when you're working with exponential roots of odd power. But so that's the key information. And to solve this, you need to know some definitions. So to start off, if you take like x to the a times x to the b, this is equal to x to the a plus b. The reason for this is, let's say we have example x squared times x cubed. This means we have x multiplied twice. This means we have x multiplied 3 times. So really, when you're multiplying them all together, it doesn't matter how you combine these. So basically, I could do it like this, or I could do it like this. Any such combination. It doesn't matter which way you combine the x's. All you need to know, you're multiplying x 5 times. So this is x to the 2 plus 3, which is x to the 5. So that's key information there. Another definition you know is if you take x to the a to the b power, this is going to be x to the a times b. So you're multiplying x 8 times, and then you're taking those, this is like a permutation. So if you take, for instance, x squared to the squared power, so you're taking x twice, and you're squaring this. Well, now you're just doing this twice. So you're squaring the x terms. Now you're taking this x and you're doing it twice. So now you're just doing this 2 times 2. So that's why you get is x to the 2 times 2, which is x to the 4. It gets more complex when you add more larger numbers. But these are the 2 key definitions that you need to know when you're solving this problem. So for quantity A, we're given x times x squared to the 4th. So we're actually dealing with the definitions 1 and 2. So what you can actually do, because anytime you multiply a number, let's say you have a times b times c. Well, this equals to b times c times a, which equals to c times a times b. It doesn't matter how you combine or the numbers. They're all going to come out to the same. So you can break this into components. What you end up doing is, let's start with the outer. Let's start with the x squared to the 4th. Based on the previous definition, x to the a times x to the a to the b is x to the a times b. This is the same scenario. So this is equal to x to the 2 times 4 is x to the 8. So that's the first one. So now we have that. We're going to combine that with the initial term, because you can do it in any such way, multiply in any such way. So this is an equivalent of what this term is. Now we're using the definition 1. So basically this is just x to the 1, because x is x to the 1 plus 8, or x to the 9. All right, so we have that. We have solved A. Now let's look for B. B is just x cubed. So you're multiplying x 3 times, and you're doing that 3 times. So, so basically, this is why you're going to have it 9 times, right? You're doing 3, and you're doing it. Twice will be 6, and then 3 times will be 9. So this, using definition 2, is x to the 3 times 3, or x to the 9. So in this case, we know A equals B. All right, so there's that one. Now the last problem I'm going to solve. So there's going to be 40 total, and this is 9 out of 40. For this problem, you're given x is not equal to 0. So we need to know, what does that mean? If it's not equal to 0, It's the set of all numbers such that all numbers x such that x is not 0. That's just one number it's not equal to. So that means x is less than 0 or x greater than 0. Now the key with this one, I'm going to do it graphically. There's a key definitions for absolute value. So if you want to know absolute value, what it actually is graphically, what you end up drawing is this. So this line right here, normally you solve y equals x. So the positive x-axis, this is positive, this is negative x. So this is the positive side, and this is a negative side of the x-axis. On the positive side, you have y equals x, and on the negative side, you have y equals negative x. What you're actually doing is you're taking the line y equals x, and you're taking a negative number, you're projecting it to the positive value. You're taking this value, you're shifting it. Equal distance. Equal distance. So the negative y value equals the positive y value. The negative y value equals the positive. See how it's symmetric? So basically all you're doing is you're taking, so when you take absolute value of negative 2, which is from right here, this is just equal to positive 2. So basically now we have absolute value of x plus absolute value of negative 2 equals absolute value of x plus 2. So now with this, what you end up doing, draw graphically again, is you're shifting it up 2 units positive. You're just adding the y, because this is y equals to absolute value. If you take y equals absolute value of x plus 2, you're essentially just shifting it up 2 units. Now the second one is y equals absolute value of x minus 2. So whatever is in between absolute value of x is what you want to consider. So what you're doing now is you're subtracting 2 from the number inside the absolute value. So essentially, if you notice with this original function, this is when x equals 0, the absolute value essentially is at the origin. But when you have absolute value of x minus 2, we know that if x equals to 2, because we know that what? 2 minus 2 is 0. The function's 0. So when x equals 2, because remember, absolute value cannot be negative. 0 is the minimum value, unless you're taking like minus, let's say we take minus some value b. If we take this whole thing minus some, that changes the y direction. But whatever's inside, anything inside the whole absolute value function is always greater than or equal to 0. So what we did right here now is we're taking the absolute value function, and it's the same, these are parallel lines. And what you're doing is, if you take 0, you plug in 0, we know the absolute value of 0 minus 2 is absolute value minus 2 is positive 2, which is right here. It's the same point. So actually this projects. So what you find here is that absolute value of x plus 2, notice how it's greater, is greater than absolute value of x minus 2 for all x, notice, greater than 0. Otherwise, absolute value of x plus 2 equals absolute value of x minus 2. So like for instance, we plug negative 1. Well, absolute value of negative 1 is 1. So 1 plus 2 is 3. You plug -1 in here, you get -1 minus 2 is -3. Well, that becomes positive 3. They're equal. But when you plug in a positive value, let's say 1. Well, 1 plus 2 is 3. 1 minus 2 is -1. That's 1. So in this case, A is greater than B in some cases, and then A is equal to B in other cases. So therefore, the answer is D. Now, if they gave you, let's suppose now, if they gave you X is less than or equal to 0, well, then it's equal. But they didn't. They said X is not equal to 0. So that's the key information that you need to consider and when solving this problem. You can also just plug in the numbers and figure out, like you could just say, suppose you take case 1, X equals -2, and you take case 2, X equals 2. So this is X less than 0, X greater than 0, and then you go from there. So yeah, I hope this was helpful. I'll continue these modules or these segments, and hopefully, I'm going to do other courses as well, like algebra, calculus. I also am creating a website. I'm working on that to distribute free information as well. If you need help with, SAT math or preparing for GRE, that's just my goal and intention right here, because I'm an aspiring teacher. And I hope this was helpful, and I'll see you next time.